In this lesson, we will be discussing the surface area of a right rectangular prism. Here on the side is a right rectangular prism and its net. So if we scroll down, this is its net, meaning it is, if I were to break it out and unfold it, it would look like this, with each of the letters representing one of the sides. The area of the net is the sum, or if I were to add up all the sides of the areas of the 6 rectangles. So when I look at this shape, if I wanted to know the area of it, I could add the area of each of these different rectangles, and that would tell me the area of the overall shape. So the area of the net is, in this case, if we look at area of angle A, or of rectangle A, this is going to be 5, and this one here is going to be 4. So I'm going to have area is equal to 3 times 4 plus the area of B, which is 8 times 5, plus the area of C, which is going to be 8 times 4, plus the area of D, which is 5 times 4. Oh goodness, I'm realizing that I have an error here. This should actually be 5. I'm not sure where the 3 came from, guys. Plus E, which is going to be 8 by 5, plus F, which is going to be 8 by 4. So if I'm looking at this, these are the areas of rectangle A, rectangle B, rectangle C, rectangle D, E, and F. And so as I go through, I can do each of the steps of math in here, remembering to follow my order of operations. So 5 times 4 is 20, plus 8 times 5 is 40, plus 8 times 4 is 32, plus 5 times 4 is 20, plus 8 times 5 is 40, plus 8 times 4 is 32, and overall, I have 20 plus 40 is 60, plus 32 is 92, this will give me 112, 152, and 184 centimeters squared. So the area of this net is 184 centimeters squared. So we see that the surface area of the rectangular prism is 184 centimeters squared. Because this shape was the folded down version of this, we know that this here has a surface area, or if I wanted to paint the entire outside of it, of 184, just like the unfolded version. The surface area of an object is the sum of the total, or of the areas of its bases So remember, this word sum means the answer to an addition question. So it is the total when we are adding. And this word faces is telling us each of the sides of our shape. Okay, so there are 3 pairs of congruent rectangles in the net of a rectangular prism. So we can write the surface area in a shorter way. Typically, the way that I like to structure this when I do this is I like to do break it into 3 different sections. So I have the top and bottom. So the top and the bottom is going to be the same size. So I'm going to find the area of the top or the bottom, and then I'm going to multiply by 2 because I have 2 sides that are that size. Then I have the front and back, which again, I'm going to calculate one of them and multiply by 2. And then I have 2 sides of my shape, which I'm going to again multiply by 2. So we're going to do an example here where I break it out like that. So example 1 is find the surface area of this right rectangular prism. So I'm going to start by organizing myself. I find the biggest thing that's an issue for students when we are doing surface area is organization. So labeling something top and bottom is really important because it really helps you organize what's going on. So my top and bottom, I'm going to use that formula, area equals length times width. And I know that the top is 3 times 8. So my area is equal to 3 times 8, which is 24. And I have 2 sides. I have the top and I have the bottom. And so my area overall is going to be 48 centimeters squared. Next thing I have is my front and my back. Now, it really depends on how you see the shape. I tend to say that this part here is my front, but some people like to call this the front instead. Doesn't actually matter as long as you guys are being consistent. So this front page or piece here that I have colored in a little bit, it has, so this is 4, meaning this is 4, meaning this height here is also 4, and this is 8. So I have my area equals length times width. So area is equal to 4 times 8, which is equal to 32. I have 2 sides like that. I have one in the front and one in the back that we cannot see. And so my area here is equal to 64 centimeters squared. And then last but not least, I have my 2 sides. Now, for my sides, I like to call it this section here. Although if you use this as your front and back, this would be your sides. And so here I know that this is going to be 3 at the top. So my area equals 4 times 3, length times width. So area is equal to 4 times 3. So my area is equal to 12. And I have 2 sides like that, one here and one on the other side. So my area is 24 centimeters squared. Now, once I know the area for each of the different sides, I'm going to need a total. So I'm going to add up each of the areas that I have. So 48 plus 64 plus 24. And that is going to give me, give me a second here. 136 centimeters squared. So this is how I like to break it up to keep it organized. And even when I do this for myself, so this is actually a skill that we use a lot because if you are deciding to paint your bedroom, you need to know how much paint you need to paint the walls. Or if you're replacing flooring in your home, again, you need to know how many square feet are on the floor so you know how much to buy. And so when I do this, this is actually how I break it down in my head so that I know what I'm doing. Now, the second example that I have for you is the school is holding elections for student council or for an SLC. The ballot box is to be painted. The ballot box is a cube with edge length 30. There is a slot in the top. The slot has length 16 centimeters and width 1 centimeter. What is the total surface area to be painted? Assume the base is going to be painted. So the first thing it says here is hint, draw a diagram. So we are going to draw a diagram. So I need a cube. Now, I'm not expecting you guys to be amazing artists. I would like it to look roughly sort of like a cube. So here is my cube. If you want, you guys can draw the invisible portion, the background. And so with that, we have our box. Now it says we're going to paint the base, so that means that we're going to paint all of the sides, but we are going to cut a hole in the top, and that hole is going to be where we put the ballots in. Now it's a cube with edge length 30, so that means that every single side is 30 centimeters. So when I'm doing a question like this, I'm going to start by looking at the different sides. Now, because it's a cube, every single side is the same. So I'm going to say that I have 6 sides that are the same. So I could do top and bottom, front and back, 2 sides, but they're all going to be the same. So mathematicians are lazy. We like to take the easiest way out. So I'm going to do area equals length times the width. And I know that each of these lengths are 30. So I'm going to have 30 times 30. So each side is 900 square centimeters. Now, I have 6 of these sides. I've got top and bottom, front and back, and 2 sides. So I'm going to multiply that by 6. And I will get overall 5,400 centimeters squared. Now that's if the box was completely covered, but we have the slot. So it says that in the top, this slot is 16 long by 1 centimeter wide, okay? And so this is not an area that needs to be painted. So we need to know how big that is. So 16 times 1 is 16, and there's only 1 slot, so we're only going to leave it like that, centimeters squared. Now this question is different because our 6 sides, we're not going to add the slot. We're actually going to take it away because we've cut that chunk of the board out. So I'm going to have 5,000, give it the title here. So our total here is 5,400 minus 16. And so overall, we need to paint 5,384 centimeters squared on our ballot box. Now, there is a document that is labeled practice questions for this unit. Please work on those. Take your time with them. Work on organization. That is our #1 thing. It's where the majority of errors come from. And if you have any questions, please let me know and via email or Hangouts.